Hey, welcome back. So recently I've been playing with a new domain-specific language, or DSL, from Microsoft called TypeSpec. Now, if you've never heard of TypeSpec before, it is a programmatic way of defining and describing your APIs up front. And up front is the key to this, and that is why I'm excited about it. And I'm excited about it for two reasons. Number one is if anybody here has ever had to deal with OpenAPI Spec 3.0, you would know that you would never ever generate those specifications up front. What you would typically do is write your API in code and then use decorators on your code to then generate out the OpenAPI spec. Now that is great for having an up-to-date version of your specification, but you're not exactly designing at that point. You're generating from your implementation. Now, the idea in the beginning of Swagger, as it was back then, was to use your spec as your design tool, but it is verbose and terrible and huge, and it's never a tool you would use to design an API up front. So in reality, what actually happens is you tend to generate those specifications from your code. However, that is not a design experience. And if you think about what UI designers do, they don't go and pick up React and then start coding against that, what their specifications are. They will actually use tools such as Figma. And if you think about that, API design needs the similar type experience. We need to define what those types are. We need to define what operations are going to be on the specification. And then from a development perspective, we can use the specification to determine whether we're meeting the specification that we built. It also allows us to have backwards compatibility between various versions. So I'm super excited about this because a programming language is exactly the right tool for doing this, but having that separation of concerns between design and development is cool as well. Now, the second reason I'm excited about this, which I'll talk about at the end of the video, is the uses for generative AI. Because actually, as we move into agentic workflows and we have AI agents that are going to start generating code for us, being able to define APIs up front and bringing that into its reasoning workflow and planning workflow, so you can give it a spec of what an API looks like and then have the AI go and generate the code from that, or even using the agent AI to go and generate your API specs based on your requirements, then having that separation from the code means that you're going to get a better output from the AI. And I'll talk about that a little bit at the end. So I'm super excited about this. So in this video, I'm going to show you how to get started with TypeSpec and how easy it is. So first things first, if you want to check out more about TypeSpec, you can go to typespec.io. And then there's a sort of guide to getting started, and there's some documentation, and there's even a playground for you to go and mess around with a couple of the examples. We're going to get started on our machine. So to do that, we are going to just install it by doing npm install -g. So I'm going to install this npm package globally, and I just need to bring in the TypeSpec compiler. And that's probably one of the most important things about this is we can take our TypeSpec definitions, and then we can compile them and make sure there's no mistakes in the specification, but also we can use that compiler to generate out to tools such as OpenAPI Spec 3.0. So now that's installed, we can just use the CLI to generate up a nice little hello world for us. To do that, we just type in TSP, which is the name of the CLI, and then init. And then it's going to give us a couple of options, which template we want. I'm going to select the generic REST API template because we are going to generate out some OpenAPI Spec 3.0 from this. So we'll select this. Project name, I will just hit OK. I'm going to select TypeSpec HTTP. And as you can see, it has created now 3 files, main.tsp, a package JSON, and a TSP config. .yaml. But now if I just type in code dot, we can open that up in VS Code. So if we look at the main TSP for a second, you see there's no syntax highlighting, etc. But we can fix that by typing in TSP code install. And now that will install the VS Code TypeSpec extension. And now if I type in code dot and we open it back up, you can see I've got syntax highlighting. You see lots of squigglies, TypeSpec import not found. So we need to install the dependencies. So I can just do a TSP install. And that will go ahead and install all of the dependencies for me. And now if I come back into VS Code, you will see that the red squigglies are gone and it's all nice and beautifully lit up. So I have now got my extension. And again, if I want to see what the extension is, I can go into extensions, I can type in TypeSpec, and you will see it's TypeSpec for VS Code, which is installed. Alrighty, so in order to bring this to life, we're gonna design our own REST API specification for an AI agent directory service. Now, to build our AI agent directory, we actually need to provide a service definition. So to do that, we are just gonna type in namespace AI agent directory. So we can think of this as a namespace is just as a way of collating all of the resources within our REST service together. Now, our namespace needs to have a couple of definitions to make sense. We need to give it a title for our service, and we also need to define a server for that. So to do that, I'm just going to put in the decorator at service. And we will just set the title as equal to AI agent directory. And then I also need to define what the server that it's going to run on. So in this case, I'm going to say it's HTTPS, and it's going to be AI agent.chrisheyuk.io. And then I will give it a bit of a description. So we'll say endpoint for AI agent directory. Now, as you can see here, I've got a couple of red squigglies, and the reason that I've got a couple of red squigglies is it doesn't know the identifier server. So to fix that, I just need to do a using typespec .http, and I'll also do a using typespec .rest. Going to need that for a second, and then you can see those squigglies go away. So if you've never dealt with a using statement before, it essentially allows you to not bother having a fully qualified name there. So if I took this if I just deleted this for a second here and then put typespec.http.server, you would see all of this goes away here. But I want to have the nice, simpler server without having to fully qualify the namespace. So I just have my using statement, and that will allow me to use the shortened version. So now that I've defined my service, one of the things that I can do is I can do a TSP compile dot, and then you can see it's came back with compilation completed successfully. And you see now there is a TSP output folder, and there's an openAPI.yaml. So there we go. It's generated me an openAPI spec 3.0. And you see it's using the title AI agent directory. The version is 0 at the moment. There's no tags or paths or anything like that. And then you see with servers, it's defined the URL of my server and then what the description is. So we are using decorators within our specification to generate out the openAPI spec that we need. Now, if I did want to version this, I could just type in import at typespec /versioning, and then we would put another using in there just so we don't have to fully qualify things again. We'll put typespec .versioning, and now I can just add another decorator in here, and we'll say versioned, and then I'm going to say it's going to be of versions. And as you can see, there's a red squiggly on the versions because it doesn't know what the identifier is. So all I need to do is define that. So we'll say this is going to be an enum. It's going to be called versions. We'll set that to being v1. And now if I do my TSP compile dot one more time, you can see it's compiled correctly. And now if I open up openAPI and you see there's a v1.yaml there, you can see version is v1. And then you see it's defined what the versions are. Notice my original openAPI spec is still around because it was version 0.00. So I don't lose my previous versions. Now, I'm just going to delete all of this because I don't want to maintain versions throughout this. But it gives you an idea that if I want to do versions, then it's fairly easy to version across my specification. So now if I just run my compiler one more time, open up my output, you can see we're back to version 0.0. So now that we understand what the service definition for a REST API is, we want to actually start having some operations and resources for our API. So in this case, I want to be able to return a list of AI agents. So if we think about how REST APIs are designed for a second, one of the things that you want to be able to do is group things together with the operation. So if I had something like / agents there, if I run a get against that, then I would be expecting to get a list of all the agents there. If I then added in something like /5, for example, then I would be expecting to get sort of agent 5 coming back there. And again, if I changed that to rather than doing a get and did a delete, I'd expect it to delete agent 5, etc. So when we think about REST APIs, we tend to group together the operations or resources in that sense. So let's come back into how this is going to look in TypeSpec. So what I'm going to do here is I'm going to create a new namespace and I'm going to call it agents. And I'm going to define a new schema or a new model in TypeSpec language, which is going to describe what an agent is. And in our terms, an agent is going to have a name, which is going to be of type string. And an agent is going to have a description. And again, that is going to be of type string as well. So now when I want to return my list of agents back, then I need an operation, which is going to be essentially going to be called list in this case. And then it is going to return an array of agents or a list of agents in that sense. So that is the simplest example of what I have here. That is a definition of an operation that returns a list of agents. And if I run my compiler for 1 second and we come back into OpenAPI Spec 3.0, you can see here is my AI agent directory service. And then underneath here, I've got my paths. At the root here, I've got an operation called agents list. And you can see it's returning, and it's generated off of the back of this model a JSON schema called agents.agent. And then you can see here it's got a name, a description. Name is of type string, description of type string. All my service stuff remains the same, but it's given me a really nice OpenAPI spec definition. You kind of see my point at the beginning of the video, how complicated this spec is. Imagine trying to use this if you're trying to design it. You would get nowhere compared to just model, agent, name, string, description, and then operation list. Much, much more simple. And remember what I was saying before about generative AI? Yeah, this is quite big for something like the context length. This is going to confuse the API. It's going to be hard for it to work with this if it's trying to define API schemas or if it's trying to generate code from the back of this. Being able to work with this is super simple for an AI to be able to deal with. And this is why I think with tool calling and generative AI, being able to use a sort of React style agents to be generating API specifications, but also to be generating code off of the back of it, I think this is going to be absolutely critical in a world of APIs. And I'll probably do another video on that at some point. But for just now, we'll continue on looking at the kind of TypeSpec language. Now, if I just run my TypeScript compiler for a second, and then we open up OpenAPI spec here, you can see I've got my agents list, but it's coming off of the top route there, right? It's the /. Really what I want to be able to do is group everything into / agents. So the way I can do that is just on top of this namespace, I can add a route and then I can specify the route. So I can just say / agents. And that if I run my TypeSpec compiler one more time and then come back into VS Code, you will see that it now comes under the path / agents. And that means every operation comes under that as well. So that now means that if I were to call that URL, and I was doing AI agents chrisheyuk.io, rather than hitting the / there, I could have that kicking off of / agents, and that's going to return the list of agents there. Now, because I want to be able to group operations there, I can add other operations in here as well. So if I wanted to, I could add a new operation, so something like get by ID, and then of course, in here, to get an ID, I want to be able to pass something like 5, and then it will return ID 5, because that's how kind of it works with REST. So I will just put in a nice thing that says path ID, and then we'll say it's going to be of type int32, and I want that to return back an agent. So now if I run my TypeScript compiler one more time, and if we open up our OpenAPI YAML here for a second, I've now got /agents. So operation is agents list, blah, blah, blah. But now you can see /agents /ID with the ID placeholder. So it will give that agents 5, blah, blah, blah. And that's all down to that nice little path, little decorator that we've got there. Now, if I come back into this a second, this is generating some pretty good OpenAPI spec 3.0 there. You see what I mean about it being verbose, right? Straight away, that's a lot of text. That's really difficult for humans to be able to design to, whereas something really simple like this is really easy for humans to get. I can design this and I can define what that spec is, but this is probably too hard for the average human to be able to deal with. And if it's too hard for a human, it's actually too hard for a generative AI as well. So if we come back into generative AI and we want to have agents that are going to be able to pick up specifications and implement code from it, or even define what good models are going to look like, then this is a lot more terse. It's a lot simpler syntax to deal with, as opposed to this kind of very verbose piece. But of course, you can generate out OpenAPI spec, which allows you to be compliant with tools. So if I want to add some documentation to this, I can just use @docDecorator and then say that would be the name of the AI agent. And then I could do the same here @doc. And we'll say short description of the agent. And then, I'm missing actually the ID here. So if I wanted to, I could even just do @doc, and we'll say ID of the agent. And then we will add a new property here, and we'll call it ID, and we'll make it of type int32. And now we have a brand new property on there. If I come back into my TypeSpec compiler for a second, we hit compile, come back into VS Code, and if we have a look here, you can see description ID of the agent, description the name of the agent, and description short description of the agent as well. So it's really easy to add things like documentation, and again, a really nice, simple, terse kind of format. Now, of course, because the TSP compiler is a compiler, if I make a mistake in here, let's say I call that agenty, for example, we're going to get some red squigglies here. If I run the TSP compiler, again, it's going to come back with some errors because it's a compiler, which is pretty cool. When I think about these AI agentic workflows for a second, being able to use tools, the AI agent would be able to come back and forward and actually use the tool to compile the things that it's generated. So I think this is going to be really cool for AI agents defining things. Now, this is pretty cool so far. I mean, these are fairly simple examples, but one of the things that is interesting about REST APIs is everything's very kind of templated. You know, most of the time you're doing kind of CRUD type operations. I need a get, I need a delete, etc. It's very, very repetitive. So one of the things that you can actually do and utilize within TypeSpec is the ability to use things like templating. So in the same way as we have our agent at the moment, you know, if I was going to design something that's going to maybe return users, for example, the REST APIs are going to be incredibly similar because I would maybe have a list of all the users on the system. I'd maybe have a get by ID. I would maybe have a delete user. Now, from a specification perspective, they're all going to look pretty much the same, except the type is going to change there. And this is where a lot of the power of TypeSpec really comes in, because it has this idea of templating. So I'm going to show you how this works with an idea called operation templates. Now, this works very, very similar to generics if you've dealt with that before. So I'm going to create a new operation. I'm going to do it outside of my agent's namespace, and I'm going to call it get by ID resource. And that is going to be of type T. Again, I said this is very similar to generics, right? And then I'm going to take the @path piece here. So we'll just take this from here. And then we will put that there, so path ID and 32, but rather than returning agent, I'm going to return back T. So it's whenever I call get ID by resource, I'm going to pass in the type, and then it's going to return back the same type there. Now, what that means is now with this op get by ID, rather than defining that this is going to be of agent, I can then say it is, by using the is keyword, is get by ID resource, and then I can pass in the type agent. Now, if I run this, you see it's all good again. If I now clear my window and then I run my TypeScript compiler again, and then we come back into my OpenAPI spec, you see everything is pretty much the same there. I've still got my schema there, ID name description, everything is the same, but it's actually taken the complexity away. So it's using this templating mechanism. So of course, now if I wanted to create a get by ID for a user, then it would be pretty easy for me to then just go users, and then I could go users, user, and then we'll say user. We'll change this to user here, change this to user here, and now it's just reusing this kind of path mechanism. So I'm very, very quickly updating my spec and rinsing and repeating. And if I run compile there for a second, and then we come back into VS Code there, there's my users. You see it's doing a users list in that sense. There's my user by ID. And then, of course, it's defined to the schema users.user. And then if I look at the underlying schemas, you can see I've got my agent schema of ID name description, but then I've got my user schema of ID name description there. And then, of course, my get by ID is running the same. So it massively simplifies the spec, and I can make changes at once. And again, if you think about this for REST APIs, most of the things that you do are templated in REST APIs. They follow kind of a CRUD type format. And where this gets even cooler is if I want to, I can sort of even use things like inheritance with models as well. So I could take that ID name description, which is pretty much repeated everywhere, and we could just pull this up here for a second. We'll say model, we'll call this ID name description, and we'll just say ID name, and we'll say description, and we can take the user that we have here, and then we could just do something like extends ID name description. And now I'm going to do the same for the agent as well, and then rather than it being agent, we can see that extends. And then if I just recompile this here, come back in, and you see inheritance works as well. So templating and inheritance together really, really powerful. That's not the only optimization that we could be making here for a second, because as we can kind of see here, you can see that this here is even patternized in itself as well. So one of the things I could do is I'm going to take these operations here, and then I'm going to bring them together. So I'm going to create a thing called an interface. And then what an interface allows you to do is group common operations together. So I'm going to call this kind of CRUD operations. And it's going to use templating. So it's going to accept T. And now I'm going to take the list and the ID here. I'm going to bring this into the interface. And then rather than returning, user, I'm going to have it return T. And now that means I can get rid of this here, and then I can just type in interface users extends CRUD operations, and in this case it's going to be of type user. And then of course I can do the exact same over here, and then I just change this to agent. And now if I just run my compile one more time, and then I come back in here and look at my OpenAPI spec, there's my /agents as before. Here's my agents list. You can see it's returning agent. There's my get by ID. So it's doing the list and the ID. All's good. It's mapped to the right schemas. I've got to users. Then it's doing the same thing. I've got users there. There's my list user get by ID. And it all works. And you can see schema wise, it's utilizing this common schema, which is ID name desk. And then down here, all the properties are kind of falling through. So this is quite a complicated OpenAPI spec already, but here, super, super simple, right? I've just got agents, and I've got users, and I'm using templating, and I'm using inheritance. Really simple. Okay, so let's say I want to extend both agents and users so that I can do an update. So rather than messing around here and adding update to both, I can just extend my interface. So I can do update. And then, of course, I want to accept in a path again. So I'm just going to say path ID, and it's going to be of int32. So I'm going to pass in the kind of the name of my object. And then I want that to return type T. Now you can see it's came back with an error here is because it thinks it's a get. And the reason it is when I provide op without its own decorator there, then it's going to default to get. So I can just update that to say at post. And now I'm passing through path ID int32. And then update is going to apply to both of these. But of course, I want to update the name and the description. I don't want to update the ID because that makes no sense. So we can do a little bit of refactoring here as well. So I can take this model. I can duplicate that here. And I'm just going to take away the name and description from here. So this is just ID. And then I'm going to extend, we'll say extends name desk. And then I can just take away the ID from the front here, remove ID. And now we've got ID name desk inheriting from name desk. And now I can then just say item of type name desk. Save that. We just run our compiler one more time. You see it's compiled, and then open API spec. There's my agents list, etc. And there's my agent updates using the schema correctly. There's my users, and then users you can see has got an update, and it's accepting in the ID within that as well. And if, of course, if you're wondering where it's taking the body in, you can kind of see here. There's my request body down here, name description, etc. So this allows you to do super complicated things really quickly. And again, it's very powerful as well. If I want to then do things like set max length on things as well, then I can just say max length is going to be equal to 10. So I'm going to have a name no longer there. If I want to have a min length of a description, I can say min length as well. And we'll say that's 20 for the description. We will just compile that one more time. And then look at the output, and then you can see that it's added max length into the schema there. So again, if you compare this Open API spec here is 159 lines versus, 48 lines there to be able to do that. Much simpler description. Now, of course, that templating technique that we're using over here, if you think about when you want to start doing things like search and filtering, etc., I can do the exact same thing for template here. And then I could say this is a kind of search type and then pass through. So if I want to search for agents, if I want to search for users, then I can use that templating technique to implement all my search and my filtering and do that in a standardized way. This is an incredibly powerful language. This massively simplifies how you can design API specifications. And if we think about generative AI in the future with tools, then I really think this is probably a more sensible way of being able to define the specs and then use generative AI to then generate out your API specifications, and then using the TypeSpec compiler to even sort of check that it works. So I think this is going to be important for AI agents that are going to create REST services. And so not only does it help humans today, I think it's great for that point of view. It's going to help you sort of design API specs a lot easier without sort of backward generating them from your code. But actually, I think it's going to make things a lot easier in a world of generative AI to get the AIs to generate good REST services, because it's simpler, it's a little bit more terse, and AI is going to cope really well with generating that. And then, of course, it can use the TypeSpec compiler to then check that its outputs are good. Anyway, I hope this video has been useful. Maybe in a future video, what I will do is, Anyway, I hope this video has been useful. Maybe in a future video, I will show you how we can use techniques such as RAG with AI and maybe use the React pattern to then actually have AI agents go and create some of these API specifications. But we'll probably do that in a future video. But I hope this has been useful, and I'll catch you on the next one.